Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code B1175 indicates a malfunction in the fuel level sensor, also known as the fuel gauge sending unit circuit, for the Honda Civic models from 2011 to 2015. This sensor plays a critical role in measuring the fuel level within the fuel tank and sending this information to the vehicle's gauge, which displays the fuel level on the dashboard. The fuel gauge sending unit is typically located at the top of the fuel tank and is integrated with the fuel pump. It uses a float mechanism that moves up and down based on the fuel level, which changes the resistance in the sensor circuit. If the circuit malfunctions, it can lead to inaccurate readings on the fuel gauge, potentially causing the driver to run out of fuel unexpectedly. This code suggests there could be an issue with the wiring, the connector, or the sending unit itself. The fuel gauge sending unit is essential for measuring the fuel level in the Honda Civic's tank. It converts the weight of the fuel into an electrical signal, which is then read by the gauge on the dashboard. The sending unit is situated inside the fuel tank, usually attached to the fuel pump assembly. If it is not functioning properly, you may notice that the fuel gauge reads inaccurately or does not move at all. This can happen due to wiring issues, connector problems, or a malfunctioning sending unit. Proper operation of this unit is crucial for the driver to maintain awareness of fuel levels, thus preventing potential engine stalling due to lack of fuel. When this error code is triggered, it typically requires immediate attention to prevent further complications down the road. There are several possible causes for the DTC B1175. One main cause could be an intermittent electrical connection, which may lead to sporadic behavior of the fuel gauge or the low fuel indicator. Another likely source of the problem could be open circuits in the wiring that connects the fuel gauge sending unit to the gauge control module. Open circuits can occur due to physical damage to wires or poor connections. Furthermore, a faulty fuel gauge sending unit itself can also lead to this issue. This may arise from wear and tear over time, as the components within the unit can degrade due to exposure to fuel and environmental conditions. Each of these potential causes requires careful evaluation to pinpoint the exact reason for the malfunction. When the DTC B1175 is present, you may experience multiple symptoms that indicate a fuel level sensing issue. One of the most common symptoms is a fuel gauge that remains stuck at the empty position, showing no change regardless of fuel quantity. Additionally, the low fuel indicator may start blinking, warning the driver of an apparent low fuel condition that may not actually exist. This can create confusion and may lead to a situation where the vehicle runs out of fuel unexpectedly. In some cases, you may notice inaccurate readings, where the gauge fluctuates erratically despite a constant fuel level. Recognizing these symptoms early can be crucial for determining whether the DTC should be investigated further to avoid running out of fuel mid-journey. The first step in troubleshooting DTC B1175 involves checking the actual fuel gauge on the dashboard. Begin by observing whether the gauge moves to the empty position when the vehicle is turned on. Additionally, check if the low fuel indicator is blinking. A yes answer to both these questions indicates that the system may not be functioning properly. This initial check helps to determine if any intermittent electrical failure is present. If the gauge operates as expected, it may suggest the system is in good condition at the moment, leading you to check for loose connections or any underlying issues later. However, if the gauge does not respond as it should, logical reasoning suggests moving to a detailed operational check in the next troubleshooting steps. The second troubleshooting step involves conducting an operational check on the fuel gauge system. First, Turn the ignition switch to the lock position to ensure the system is safely disconnected from power. Next, you will need to disconnect the fuel gauge sending unit from its 4P connector, which is critical for isolating the fuel gauge circuit from the sending unit. After disconnecting, you will create a temporary connection by linking terminals A and B using a 2-ohm resistor and a jumper wire. This simulates a full tank. Following this step, remove the number A2910A fuse from the underhood fuse/relay box for about 10 seconds to reset the gauge system. Reinstall the fuse, turn the ignition switch to the on position, and observe the fuel gauge. This method effectively checks whether the gauge operates correctly by moving to a full position, indicating all circuits up to this point are functional. In this third step, an open wire check is performed, focusing on the fuel gauge plus line. The voltage measurement is taken between 2 test points while ensuring that the ignition is in the on position. You will require the fuel gauge sending unit 4P connector to be disconnected during this check. Statistically, test point 1 is located at the gauge control modules TAC 32P connector number 22 PUR, and test point 2 connects to the body ground. If voltage is present, it indicates a proper electric path, implying that the gauge control module is functioning correctly. However, if there is no battery voltage during this test, it indicates an issue along the wiring path that needs to be repaired, or it may necessitate a replacement of the gauge control module to restore functionality. The fourth troubleshooting step checks the continuity of the fuel gauge line. First, ensure that the ignition switch is turned to the lock position. Disconnect both the fuel gauge sending unit 4P connector and the gauge control module TAC 32P connector to initiate an isolated test. Then, perform a continuity check between 2 designated test points. Test point 1 is at the gauge control module 32P connector number 21, LT blue, while test point 2 connects to the fuel gauge sending unit 4P connector number 4, orange. If there is continuity between these points, it suggests that the wiring is intact, and the next step would be to replace the fuel gauge sending unit. If there's no continuity, the possibility of open or high-resistance wiring issues arises, necessitating repairs on the wiring harness to ensure a complete circuit. After performing all troubleshooting steps and necessary repairs, it is critical to verify that the system operates correctly before completing the service. Start by checking whether the fuel gauge functions properly, moving to the expected readings in accordance with the fuel tank level. It's equally important to look for any reoccurrence of the DTC B1175 by performing a diagnostic scan. This ensures that no underlying issues persist that could trigger the trouble code again. Following this diagnostic verification, take the vehicle for a test drive to observe if the fuel level readings remain steady without any erratic behavior. Successful verification indicates a job well done, and the issue has been resolved effectively. Preventive maintenance is essential to avoid future occurrences of DTC B1175 and fuel gauge problems. Regularly inspecting the connectors associated with the fuel gauge and its sending unit can aid in identifying any signs of wear or corrosion that could lead to electrical failures. It is equally important to check the wiring for any signs of damage, including fraying or exposure, which can contribute to an open circuit or high-resistance issues. Monitoring the performance of the fuel gauge is crucial. If you notice fluctuations or inconsistent readings, it is wise to address these concerns promptly. Performing these preventive checks and maintaining a clean electrical system can significantly extend the life of components and enhance the vehicle's reliability. In conclusion, understanding DTC B1175 and the significance of the fuel level sensor is critical for Honda Civic owners from 2011 to 2015. This diagnostic trouble code highlights potential malfunctions in the fuel gauge sending unit circuit, which can lead to inaccuracies in fuel readings and potentially cause driving inconveniences. Completing thorough troubleshooting ensures that all components, from wiring to connectors and the sending unit itself, are functioning correctly. By following a systematic approach to diagnostics and performing necessary repairs, you can effectively resolve issues related to fuel level sensing. Additionally, implementing preventive maintenance measures will safeguard against future occurrences, enhancing the vehicle's reliability and performance. Please like and subscribe to the channel. See you next time.